Hello, my name is Morgan Benner. I'm the telemetry lead for the KCAL Solar Car Solar Crusaders, and today I will be talking about our telemetry system, including the TI84 CE+ with Python. So firstly, I'd like to talk about the general goals and objectives of our telemetry system and then integrating the calculator specifically into our existing telemetry system. Our primary goal in our telemetry system is creating an effective human-machine interface, which is communication between our sensors and our Arduino and our car and the people interpreting that data, the humans. So this leads me into three telemetry sub-goals: gathering data, transmitting that data, and analysis. So gathering and transmitting the data is fairly self-explanatory. That is where we get the signal and then transmit the signal from the Arduino and the sensors to the displays. And then the analysis is the human part of that human-machine interface where we take that information and then use it to improve our vehicle. This is our current telemetry system. We have the Arduino hooked up currently to a breadboard. That's some code that we loaded onto it. And on that breadboard, there are other various sensors, including a light sensor and a GPS. And then there's a more zoomed in picture of that breadboard Arduino connection. This is our telemetry box. It's what we use to store our telemetry components and modules on the vehicle. In this box, we will have our Innovator Hub, our Arduino, and various other telemetry modules used for communication. So we plan on using the TI84 CE+ with Python calculator as a driver display for our vehicle. So we like this because it fulfills our two main display goals: legibility and flexibility. We want to clearly and concisely display information to the driver while in motion, and we also want the ability to tailor what information we are displaying to the specific circumstance. So integration is really important for us. We want to use this calculator not just to check off a box in this competition, but because it is a valuable tool in helping us safely and clearly display information to the driver. This leads me to our display models. These are test screens, test subscreens that we brainstormed, and we thought about what we wanted in a display, and this is what we came up with. So our three major ideas were a test screen, a troubleshoot screen, and a drive screen. A test screen would be specifically focusing on one sensor and then clearly displaying that information. A troubleshoot screen would be more for the telemetry team than the driver, where we could hook it up to the car and see a lot of information densely and clearly explained and shown. And then a drive screen would be familiar to the driver. We'd have a speedometer and a battery discharge, information that is pertinent to the driver while in motion. And so here are the samples of each of those screens in the order of test, troubleshoot, and drive. As you can see, the test screen is very high contrast and it's displaying that information very legibly. The troubleshoot screen is denser but still very clear, and it has a lot more information in it. And then the drive screen, we have a speedometer and a battery discharge meter, which allows the driver to see very clearly what's happening in a way that they understand. So implementing the ideas that we previously talked about is in our wiring and setup. This is a schematic of our telemetry box, which includes our Arduino and our Innovator Hub and all of the components I previously talked about. And then here is a more detailed connection between our power bus, our Arduino, our calculator, and our Innovator Hub. We are using the power bus to power the whole system, and then we are connecting the Arduino to the breadboard on the Innovator Hub. We're using both analog and digital displays because we have a lot of information that we wish to display. And then the Innovator Hub is connected to the calculator via mini USB port. Here is some more information about our wiring, and as we were wiring our system and hooking it all up, we came into some challenges and issues in realizing some of our previous ideas. So the first issue we encountered was the issue of screen navigation. The TI84 CE+ with Python does not allow non-blocking interrupts, which means the driver cannot press a button and navigate through separate screens in the program. If we wanted the driver to see a different screen or go to a different level of data intensity, then they would need to exit the program entirely and then upload or reload a new program, which is just not feasible for a driver to do time-wise, especially because they need to focus on the road. The second primary issue we faced was the issue of memory. Memory is very ample in the calculator. We have a lot of it. However, it limits how much memory and lines of code the specific programs can have. So the complexity of screens that we wish to have in colors and contrasts and shapes is sort of halted by the amount of code that we're allowed to have. And so our main solution to this is just dumbing down and simplifying our code to fit the memory constraint. But that is not ideal for us because we want to be able to use the calculator and its display capabilities to its full potential, which we cannot under the current memory constraints. The final major issue that we've currently encountered is the issue of documentation. The Innovator Hub has an I2C port, which would be very useful in communicating between the Arduino and the calculator. However, information surrounding the I2C port and communication with other products is very, very limited. Compared to other telemetry and sensing products that we have on the vehicle, like the MPPT and the motor controller and the Arduino, the information surrounding the Innovator Hub and this calculator is very limited. The Arduino, for example, is open source, and there's a lot of community and company support in projects that you'd like to take on with the Arduino. However, this is not mirrored in the Innovator Hub. We don't have that same level of support, and so as an educational opportunity, it's very frustrating to have to try and find information that does not exist and has not been provided to us. In conclusion, we are very excited as a team to continue using the TI84 CE+ with Python as a driver display, despite the fact that we have faced challenges. It has been an enriching and fruitful learning experience for me and my team, and we are excited to continue. This is my team, and thank you.